First, this is the question. Solve the following system of equation, these three equations, with the help of the Gauss elimination method. First one, the given system of non-homogeneous linear equation can be written as in matrix form as Ax is equal to B. First, in the A we have to write the coefficient of the coefficient of this given equation. So 1 minus 1 1 minus 3 2 minus 3 and then 2 minus 5 and then 4. Then x is the unknown value x y z, here also x y z and x y z. So we write x as x y z and B is the column matrix. This is right hand side part, 1 minus 6 and 5, 1 minus 6 and 5. This is A, this is X and this is B. Now the augmented matrix A partition B is equal to 1 minus 1 1. Combination of A and the B is known as augmented matrix A partition B. Next 1 minus 3 2 minus 3 minus 6 2 minus 5 4 and then 5. Now in Gauss elimination method, we have to bring first a matrix into a upper triangular matrix. For this upper triangle matrices, these three have to become 0. These three have to become 0. Upper triangle matrix is nothing but below the principal diagonal elements, the remaining element should be 0. So this is principal diagonal elements. Below this 3 minus 3 2 minus 5, this should become 0. So first we have to convert this into upper triangular matrix. So let's convert it. First this has to become 0. So we do the operation R2 tends to R2 plus 3 R1 and then this has to become 0. So R3 tends to R3 minus 2 R1. So let's write the same of R1. First minus 1 1 minus 1 1 and then 1, and the next R2 is minus 3 plus 3, this is 0, and the next 2 plus 3 into minus 1, minus 3 minus 1, the next minus 3 plus 3 into 1, so then 0, and the next is minus 6 plus 3 into 1 is minus 6 plus 3 is minus 3, so here you get minus 3, and the next is R3 is what? R3 minus 2 R1, so 2 minus 2 into 1 is minus 2, 0, and the next minus 5 minus 2 into minus 1 is plus 2, nothing but minus 3, so we get 0 and then minus 3, and then 4 minus 2 into 1 minus 2, so we get 2, 5 minus 2 into 1, so 5 minus 2 is 3, so we got this and this as 0. So now we have to make this as 0. We have to use only row 2 to make this as 0, because this has to not change. If we multiply this with something and add this with this, so we get the another value, 0 gets displaced, 0 gets placed by another number. So we have to remove this minus 3 and keep here 0 by using the elementary operation only with row 2. So R3 tends to R2, R3 tends to R3 minus 3R2, so that here what will become is minus 3 and minus 3 into minus 1, what we get? Plus 3, so total it becomes 0. So now let's apply R3 tends to R3 minus 3R2. So first let us write first and second row as same, 0 minus 1 0 and then minus 3 here, and then another one is let's change R3 is equal to 0 first before matrix it was like this. R3 was like this, 0, -3, 2 and 3, and R2 was like this, and R1. I'll let all of these values. 1, -1, 1, 1, 0, -1, 0, -3. So we have to do R3 minus 3 R2. R3, 0 minus 3 into 0, we get 0. So here 0, and the next what, -3 into -1. So what we get, -3 plus 3 is 0. Here also 0, and the next 2 -3 into 0, that means what, 2, and the next 3 -3 into -3, so we get 3 plus 9, that is nothing but 12. So here we get 12. Now we have to equate this with this. This is what, z. 2z is equal to 12. This is -y plus 0z. Here this is the coefficient of x, here y, this is z. So we write here as 0x plus 0y plus 2z is equal to 12, and then down equation is 0x minus y plus 0z is equal to -3, and then up one is x minus y plus z is equal to 1. First we get here z is equal to 6. Substitute this at here, or else on it we get substitute this as here, we get here y is equal to 3. Substitute z and y at here, so we get x minus 3 plus 6 is equal to 1, x plus 3 is equal to 1, x equal to -2. We get the values of x, y, z as -2, 3, 6. So we can verify now. The given equation was, first let's take the first equation, x minus 4 plus z is equal to 1. Let's verify this with the answer we have been got. X is -2 and y is 3, and the next z is 6 is equal to 1. Let's check LHS. -2, -3, -5 plus 6 is equal to 1. So here 1 is equal to 1. Verify. So our answer is x comma y comma z is -2, 3, 6. This is how the Gauss elimination method is.